All right, isosceles and equilateral triangles. So obviously you guys know an isosceles triangle is a triangle that has two of the same sides. Equilateral triangle is a triangle that has all three sides equal. You're probably thinking, what in the world? This is going to be super easy. Well, yes, but there's a couple of things that we need to know about isosceles and equilateral triangles, specifically involving their angles. So first off, you know that for isosceles, the two congruent sides are called legs, but the angle where the sides intersect is called our vertex angle. So this B right here is our vertex angle. And the side opposite that is what we call our base. And these are our base angles. So 2 and 3 are our base angles. These angles are really important because what we know from them is that if these two sides are congruent, then these base angles have to be congruent as well. So that's the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of those sides are also congruent. So in this case, if AB is congruent to BC, if those two lines there are congruent, then we know that angle A is congruent with angle C. Right? And then there's also a converse of that. If I don't give you the sides, but I do give you the two angles. So in other words, if I said angle A is congruent with angle C, and I gave you that, then you would know the opposite of this theorem is also true, that those two sides are congruent. So it can go both ways. So for number one, these two sides are congruent, so we know the two base angles are congruent. That means that J has to be 68. And what we would do there is use triangle sum theorem, and 68 plus 68, subtract that from 180. That will give us 44. For angle 2, it's the same thing. We know that these two base angles are congruent, but they didn't give us either one of those base angles. All they gave us was the vertex angle. So what we could do is we could take that vertex angle and subtract it from 180. And then we know that those two base angles are congruent, so we would take that 74 and divide it by 2. That will give us our two base angles. So now we know, here's the converse of it. They gave us these two having 77 degrees. So if we have two angles that are next to each other and are the same, then we automatically know that the sides opposite those two angles are congruent. So what I mean when I say opposite is that, look at this 77. And if I put an arc around it, it touches two sides, right? It touches YZ and it touches XZ. So the angle opposite of that one is this 12 centimeters. Or the side opposite of that one, I apologize. The side opposite of that one is XY. So then we can do the same thing here. For angle X, it touches XY and XZ. So the side opposite of that is YZ. So those are how I get the opposite sides. What I mean by that is the side that the angle is not touching. So YZ would have to be 12 centimeters. And then we could use triangle sum theorem to find angle Y, 77 added together, subtract from 180. That will give you 26 degrees. Some of these are pretty simple, and I'm not going to go into a lot in depth on this. For number 4, you can see that those are the two base angles. They are going to be congruent, so we would set those equal to each other and solve. For number 6, anytime you have these two arcs, that denotes congruency. So we know that the two angles there are congruent. That means the sides opposite them are congruent as well. So you can solve that out in your spare time if you'd like. But for the backside over here, this is something where they did not give you a diagram, and I want you to draw a diagram. Okay, I really want you to make sure that you do draw a diagram so that you can see it and label it correctly. Okay, so if we have RST, in this triangle RST, we know that RT and ST are congruent. So I want you to know that it doesn't have to be these top two sides every single time and these bottom two angles every single time, especially if you change around your letters. If I put the R, S, and T in different spots, or if you put the R, S, and T in different spots, the different angles, maybe for yours it'll be the top two angles, or the top one and the left one, and maybe for On somebody else's, it'll be the bottom two or something like that. But as long as you keep the angles the same and label them correctly, you will still get the right answer. So if you're kind of not following along, if I didn't explain that well, somebody else might have TSR or something like that. And then RT and ST would be congruent. So for them, their angles will be here. For you, your angles will be here. Either way, it's still the same as long as you label them correctly when you plug in these expressions. So either way, we know that R and S are congruent. So the measure of angle R, 9x plus 2, is congruent to the measure of angle S, 13x minus 18. So when you solve that, you get x equals 5. So then you'll just take that 5 and plug it back in. So when you plug that back into R, 9 times 5 plus 2 will give you 47 degrees. And we already know that R and S are the exact same, so we don't even have to plug it in for S. If you decided to, if you did 13 times 5 and then subtracted 18, you're still going to get 47. So that's a good way to double check. But then we'll take that 5 and plug it in for T as well, and that will give you 86. Now, another way to get 86 is we already know that R and S are two sides of that triangle, so we could just subtract that and get the third, or two angles of that triangle, and we could subtract that and get from 180 and get that third angle in the triangle. For the next one, WXY, so let me see if I can switch it up and change it from how I did before. I did RST, let's do WXY. So for this one, WX and WY, wow, that's the exact same. Let me switch them up. Let me do WXY. Let's see if that changes it. So for this one, WX, it says right here, WX is congruent to WY. So now they're on this side. And our two angles, it doesn't matter how you draw the triangle, either way, our two angles that are going to be congruent are X and Y. So we'll take X and set it equal to Y. Sorry for making such a big deal about that. I just know in the past, a lot of students have really struggled with, and that's not right, is it? 2x, no, that's right. A lot of students in the past have gotten confused when they copy it down or they do it on their own, and we're on homework for this, and they don't necessarily keep the two angles in the bottom. So if you go and look at the answer key, on the answer key, I believe that they did the base angles on the bottom every single time, but that would take you having to figure out which one it is. And figuring out where to put which one. I want you to understand that it really does not matter where you put them. If I put W, X, and Y, or if I put, W, X, and Y, it doesn't matter. Either way, WX and WY are congruent. So X and Y, the angles will be congruent. Same thing here. WX and WY will be congruent, so Y and X's angles are congruent. It doesn't matter which way you rotate it. As long as you label them right, you will be perfectly fine. So X would be 18 when you solve that out. You can plug in for X and Y because they're the same thing. So you plug that in for X and you'll get 78. You know that they are the same as Y. Add those together, subtract from 180, that'll give you 24, and that is W. So for equilateral triangles, it's the same concept. And you know that if it's equilateral, then all the angles have to be the same as well. But here's kind of how this works. So we know that if there's two of them, then we know that these two angles have to be congruent. That's isosceles. But if we add in that third side that is also congruent, then we know this other angle opposite of it has to be congruent as well. So that's where we get equilateral triangles from. Technically, an isosceles triangle is any triangle that has two or more angles. So technically, an equilateral triangle has two or more congruent sides pairs and congruent angle pairs. So an equilateral triangle is an isosceles triangle as well. But a triangle is equilateral if and only if it's equiangular. In other words, the angles have to be the same as well. So if the angles are all the same, then we know that the sides are all the same. And that should be congruent there. And then if the sides are all the same, then we know that the measure of the angles are all equal as well. All right, so for number 11, find each missing measure. So if we have 60 and 60 here, we know those are congruent. Then we know the sides opposite them are congruent, but since those are 60 degrees, 180 divided by 3 is 60. So each one of these has to be 60 degrees. So that means we know that each side is 9 feet as well. So the measure of an equilateral triangle, the angles will always be 60 degrees, but the 9 feet there, the actual lengths of it doesn't really matter. So I could give you a triangle like this, like super tiny, and I can tell you that it's equilateral and all those angles are 60. Or I could give you like a massive triangle and I could still say, hey, that's equilateral. Either way, all of their angles are still going to be 60. Okay, so I want you to understand the difference between that. We're not necessarily talking about the angles can have, these equilateral triangles can have all sorts of different sizes, but the shape and the angles of them will be the same. So for number 12, kind of self-explanatory here. If they're all three the same, all of the angles will be 60 degrees. All right, and then for 13, if it's an equilateral triangle, solve for x and y. So first off, solving for x, we know that if it's an equilateral triangle, each angle will be equal to 60 degrees. So we will add 3 and divide by 7, and x will equal 9. For y, it doesn't really matter which two we pick here. I'm going to pick the two that have the smallest numbers, and we know that they are congruent. So we're going to subtract the 9y and add over the 23, and y will equal 12. 9 and 12 are your final answers there. So in summary, we know that if an equilateral triangle has all equal angles, then we know the sides are going to be congruent. Sides and we know the angles will all be congruent and they'll all be 60 degrees. When it comes to isosceles, the two angles across from them are congruent and the two sides are congruent. So our two sides, our two equal sides, the angles opposite them are congruent. You really need to know this stuff. We use this and apply it to all sorts of different geometric figures and shapes and stuff like that. And I just can't talk today. I'm just messing up with my words, but that is perfectly fine. I do want you guys to understand that soon enough, I'll give you all sorts of puzzles and all sorts of different topics where you need to know this stuff and to be able to apply it to parallel lines and transversals. We'll do a practice where we're chasing angles, where it's just, I'll give you probably 60 angles or so on one big diagram, and you can find all of them using isosceles triangles, using parallel lines and transversals, using our